This video is on complex numbers. We're going to be talking more specifically about what a complex number is. We're still dealing with imaginary values, so from a previous video I talked about imaginary numbers. Imaginary numbers is when you take the square root of a negative value. So the square root of -1 is I, which is what gives you the imaginary part. So again, just a quick recap. Square root of a -25. I would normally be able to take the square root of +25, which is give me 5. But if I were to press enter on here, the error says non-real answer. Imaginary is a non-real value. So that means that if I were to take the negative out, I could then take the square root of that value. So if I were to put in I, then take the square root of 25, that would be possible. So that's where this came from. Square root of 25 times the square root of -1. -1, square root of -1 is the I value. So we can just, whenever we see that negative, we know that that's going to be an I on the outside. The negative inside the radical is what we focus on. If there's a negative outside the radical, so if I were to take negative square root of 25, the 25, the radicand, is still positive, so my answer would just be a negative times the square root of 5. Or sorry, negative times 5. Because that negative is the coefficient, which is not inside the radical. So a complex number, what is a complex number? We have a plus bi. The a part right here has no I on it. That means that the a, this part, is the real number. This is the real number. Because, again, in the error, we saw it was a non-real value. When I took the square root of -25, it was non-real. So if I took the square root of 25, it would be real. So plus bi. So the bi, because it is attached to the I, this is where we get the imaginary part from, or which is what we call the complex. So this is the imaginary or the complex part. You might see either one of these words, imaginary or the complex. So it's because it's attached to the I. Whenever we write a value, we always put the real part is always first. So the real part is always first. So we always want to make sure that we have, like up here, we have 11i. The 11, we want to make sure is first. Now this is just an imaginary part. This is the bi part. So this would actually be 0 plus 11i. The 0, I don't have to write because 0 plus 11i is still just 11i. So we're going to do, on this example here, it says name the real and imaginary part of 7 plus 4i. So the 7 is first, and it is not connected to an I, so the 7 would be the real part. So 7 is the real, and the imaginary part would be the part that's attached to the I, so that's the 4i. Now this is a positive 4i. And I do put a little tail on my I so I can distinguish between an imaginary and just a variable of, let's say I wanted to use I as a variable. We never should, because I stands for imaginary. So we don't want to be careful with that. So the real number you always want to write first because it's real, then imaginary. Same thing, we always want to write the rational number first, then the irrational, which is one of the reasons why up here, if I were to say 12i, then the square root of 3, square root of 3 is the irrational. The number of 12 would be the rational part. I is the imaginary, so this would be 0 plus 12i square root of 3. So if we're going to do some operating of imaginary or complex numbers, adding and subtracting complex numbers, we only combine like terms. So the real numbers combine and the imaginary numbers combine. We do want to simplify because it's possible that we could have an I squared, I cubed, or I to the 4th. And remember that these I to an exponent have an actual value. It's not a variable which like x squared would just stay as x squared, but I squared is actually equal to -1. So we have to be very careful about that. So when you're adding and subtracting, you're going to do just like you would normally do with combining like terms. Your 6 would go with your 1. So this would become 6 is a real number plus your 1 is your real number. Then we'd have now we got to do our imaginary part, the complex part. We have a -4i plus a +3i. And now we just combine our like terms. So we have the real part is 6 plus 1 is 7. Then we have our imaginary part, which is the -4i plus the 3i, which is a -1i. So -1i. Now, I to the first stays as I. I to the first is just I. So this is our final answer. 7 minus 1i. You can also see it as 7 minus just I. 7 minus I is the same thing. So if we do this next one, we're going to do the same thing. We have our real number, which is 4. Minus is in the middle. Our real number on this next set is 3. Then we do the complex part, the imaginary. This is -6i minus a -7i. So this minus a negative actually turns into a plus sign. So when we do that, we want to make sure we simplify that correctly. So we have 4 minus 3 is 1. That's our real part. And then we have -6i minus a -7i. So that's really -6i plus 7i. That becomes a positive I, so it's just plus 1i, which is just could be written as I. So 1 plus I. That's our final answer. Now, we're going to follow the same rules if we're finding an x and y value. So it's saying let x and y just be real numbers. So these are going to be numbers, so x and y will be actual numbers, and they won't have an I connected to it. So we have x would be a real number. So we're going to write this out as x is the real number minus the next real number is 7. Then we have the equals, and then 12 is the real number in our answer. Then we can do the imaginary part, the y. Well, y is attached to an imaginary number, but y will just be a number. So when we do this, the yi does go together. So we have the yi minus the -3i, which is equal, and then the imaginary part of here is the 9i. So now we can just solve for the variables. So I'm solving for this variable for x. I want to add 7 to both sides. And we get x is equal to 19. For the y, I see that minus negative, this is really a plus. So now I have to subtract the 3i. So we end up getting yi right now is equal to 9i minus 3i is 6i. Now I just want the y value. See, if you notice, these both have the I on it already. So the y has to be the 6 to make them the same. So y is equal to 6. And those are our two values. So x is equal to 19 and y is equal to 6. Y is not 6i because we already have the I on there. I just wanted to figure out what the y value is. So let's try this last one on finding the x and y value. So I'm going to follow the same rules. My x plus, it has no I attached to it, so I know I have to go to the real part. 9 is equal to the -3. Then I have the yi plus the negative 4i is equal to the negative 14i. This is just a smudge over here, so it's equal to negative 14i. Now we're just going to solve. So to get x by itself, I need to subtract the 9. So x is negative 3 minus 9 is equal to a negative 12. This next one on the yi, this is really, so it's plus and negative, it's really just minus, so I need to add the 4i to both sides. And we end up getting yi is equal to negative 14i plus 4i is negative 10i. So again, I only want the y part of it. The I is already there, so y is equal to just the negative 10. So we have x is negative 12 and y is negative 10. Again, it said that x and y are real numbers. The y is attached to the imaginary, which is fine. We just wanted to know what the actual value of y was to make them the exact same. We already have the I on both of them, so then the y has to be negative 10 to make them be the exact same. The last type we're going to do is multiplying complex numbers. Multiplying complex numbers, we have to make sure to distribute and then simplify. So we're going to multiply like normal. So we take our first term, so 6 times 1. 6 times 3i is a positive 18i. Negative 4i times 1 is negative 4i. And negative 4i times positive 3i, so that's negative 4 times 3 is negative 12. But then I times I is I squared. We have to make sure we're careful on that. It's just like if it was an x. The only difference is that I squared equals a value instead of just being I squared. If we remember, I squared is actually equal to a negative 1. So what we have here is 6 plus, let's go ahead and combine our like terms here. 18i minus 4i is 14i. Then we have a negative 12 times the negative 1, which is a positive 12. Because that's negative 12 times I squared, so it's negative 12 times negative 1 is positive 12. But that means we still have two real parts. We have to combine those. And we'll get 6 plus 12 is 18 plus the 14i. And that's our final answer. Because we have the real and then the imaginary. So we're going to do the same thing on this problem. We're going to distribute. 4 times 3 is 12. 4 times negative 7i is negative 28i. Negative 6i times 3 is negative 18i. And then negative 6i times negative 7i is a positive 42i squared. So again, before we continue, we have to make sure we remember that I squared is really equal to a negative 1. So if we rewrite this, we have 12. We can combine these like terms. Negative 28i and negative 18i is negative 46i. And then we have a positive 42 times a negative 1, so that's negative 42. So now we have to re-simplify by doing 12 and then the negative 42. So 12 minus 42 is a negative 30. And then we have the minus 46i. And this is our final answer because we have the real value and then we have the imaginary value.